Hi guys, how are you going? So the topic today here is to explain how did did this project rail design according to the received assemblies and sub-assemblies, and inside it we rebuilt assembly in Civil 3D using the tool called subassembly from polylines. So here what we have, I received from a client one specific typical section with these two characteristics related to the track and the slipper, ballast, sub-ballast, and so on. And you have also the rock and the foundation. And the below of this one we have a channel or something like a ditch when we have we have in a cut condition. So to create this we need to use subassembly from polyline. So we can see here create subassembly from polyline in this section inside the interface, and you create assembly and to use to draw some like objects from the CAD, object type from the CAD. For example, polylines, mainly the polylines, and using this command you need to convert in subassemblies. So what was done, have done this, and we use inside the corridor. So when we go direct to the corridor, have a switch for this drawing. We have the multiple typical section, the multiple assemblies along the whole of the corridor. So for create this, we created 3 assemblies and sub-assemblies, the three different kind of sub-assemblies regarding to the embankment. So we have here these characteristics, ballast, sub-ballast, and rock, and so on, and you can draw a link width and slope representing this situation of our earth movement, and this other situation to consider the slope. So in this manner I draw in this exactly detail. So for this we have the embankment condition. For other two we have I considered the wall, inputting this vertical link, the name of this, and the last use a link region slope to reach the surface. Okay, so inside the corridor you have this situation, this other situation, and the last we have also the situation excavation. So I will put now for you see. You can see have this. Consider the base of this surface. Okay. So as you can see, we have the sub-assemblies converted with each shape code, point code, and link code in the different colors and hatches. Okay. So again, inside the corridor, when we switch in the same project, we have this rail. Important point is I'm not considering the cant now, because for this the proposal of this design is just to recover on one existing rail to extract some quantities. So we can extract the quantities directly for each layer that we have here. Okay, so here what we have a link, consider the embankment and the excavation, and for this I needed was necessarily to create two different kind of corridors. The one kind of corridor is this one that you can see, the excavation, and without any detail of this rail. And when we put in a 3D visualization, have just this, the cut. Okay, and in our other hand, we created a corridor considering the characteristics of this rail. As I mentioned before, without considering the cant. So we have here this situation. This interest point is to mention that we needed to consider the refill, I mean the embankment over this excavation. Okay, so this is a result of our design. Okay, if you observe the surface, we have all these two different surfaces. So have the surface for the rail, the top of the rail, the bellow of this the surface, consider the excavation. Just to select here the surface. One moment. Here, I believe. Let's see. Okay. As you can see, the track and the etc. And in specific station, we needed we have a complex situation, because we needed to consider this this subassembly to create excavation for this topography, existing ground, and after in the future step to create the embankment, reaching this last level of the surface. Okay, and when we go to the volumes, we have this situation. We have the data for each detail of this rail. That's the goal of, that was the goal of this design done in the past. Okay, I think that's the general idea that I would like to bring it to you today. Okay, and just to the last tip is, when you need, if you need to detail or more deeper your design, you need to use a subassembly composer. So just one simple example that I developed I developed one simple box representing this, for example, the first layer of your rail, typical section from the rail, and you need to input the how do you say, resource that name can't. So in terms of calculate the can't, you need to create this. Let's see if I create a new blank example here, just to see. You can put auxiliary point that we had in another example here, to connect the two points that you use this can't. So here I have auxiliary point 2, auxiliary point 3 between this switch, and the software you recognize this link as to apply this calculate for the can't. So between the left rail and the right rail, the Civil 3D you calculate for you as I can explain as super elevation of the rail. The can't is a super elevation of the rail, and the box is representing here in this radius. I am using a 110 meters for these radius, and if you use a can't tool, the software will ask you which data you need to put in this dialog box. So here I adjusted, I did it one specific design criteria to use this formula, and this with these mathematical items. Okay, and you can observe that the software you simulate this, you recognize this calculation. Okay, and here I have a difference between the top of the bellow level and with the difference more or less almost 10 in this case, almost 20 in this other case. Okay, so that was a tip that I bring today, and see you. Bye bye.